This is a short video to introduce you to the first part of multitasking the Arduino part 1. I was very deliberate with how I titled this particular entry because this entry mirrors that of the Adafruit entry multitasking the Arduino part 1. The difference between the two entries is that the Adafruit entry addresses the application by using classes and introduces classes and how to use them, because in C++ you have the ability to use classes, and in C you do not have the ability to use classes. So I'll use something different. I'll use a combination of structures and arrays to accomplish the same application. Now, I've also mirrored the headers so that you can see when you're on the Adafruit site, when it discusses ditch the delay and you scroll down and it says using millis for timing. On my site as well, I'm saying using millis for timing. Now, one more thing on the Adafruit entry, I think that is a phenomenal tutorial. I would recommend reading it and reading this one and using this one to accomplish the task in C. Um, However, I think that's just a phenomenal tutorial, so kudos to Adafruit. So in walking through millis for timing, I'm going to review what's the difference between the C version of Blink Without Delay versus the C++ Arduino version of Blink Without Delay. And I call out four fundamental bullet points here. The first one is one that if you've done any programming in AVRC already, you already know, and that the setup and loop constructs that the Arduino uses are replaced by initialization code, the main function, and then a while loop if an infinite loop is required, so a while one loop. And so that's the first thing we do. The second thing we do, we need to make sure that we have the includes required for the functions we're using. So in this case, we're using pin mode and digital write, and so we have to include those two headers. I also call out sysclock.h as a header that's required because that's required for init sysclock2, which is the clock that tracks the millisecond timer. And so when you say init sysclock2, it provides the initialization code and starts the millisecond timer, and you're able to time things in millis. If you have more questions on how that works, you can click on millis here on this hyperlink, and that'll take you to a page that discusses timing on the AVRC system. I also go with the AVR standard types of UINT8 and UINT16 instead of int and long int for two reasons. One, for embedded programming, it's a best practice to use those variable types or those data types instead of int and long int. And second, on millis, we only return a 16-bit result. So we're using UINT16 instead of UINT32 because I only deal with the 16 bits. Counting millis to 65,535 and allowing it to loop around again is fine. That's 65 seconds over a minute. And typically you don't do functions that time longer than a minute. You can implement the code to do that if you required. And then finally, this is something I don't understand on the Arduino, is that there's a very simple command on the AVR8 microcontrollers that allows you to toggle a pin by just writing a 1 to a particular port pin. And so I introduced, not only is there digital write high and digital write low, but there's also digital write toggle, which just simply changes the state to the other state. And so if it's high, it goes to low. If it's low, it goes to high. And that simplifies the code for this particular example. Now, we'll be tracking the state in our next example, but we won't do it in this one. So to walk through the code very quickly, as I said, we've got our three includes for pin mode, digital write, and sysclock. Then we have our constants. Now, I am showing that it's good. It's a best practice to go ahead and use the keyword constant when you know you have a constant. And this is a good practice to get into. The compiler will check if you try to change that variable. And if so, it will signal an error. And so it's a good way of ensuring that your code is following best practices and you reduce the amount of bugs that might be introduced. Variables you do not want to use the constant on. So where we're tracking our millis, we won't use the constant. We'll just say previous millis and initialize it to 0. As I discussed, we've got a init sysclock2 here, which simply initializes the clock and starts the counter. You only have to do that once. It's much like pin mode. You have to set up pin mode once to set up the pin, and you have to do sysclock to set up the specific clock you want. And so we also set up our pin to be an output. And then it's a very simple code. We just simply, we get our current milliseconds and we see if the current milliseconds minus the previous milliseconds is greater than our interval, which is 1000 right here. Interval equals 1000. If it is, then we toggle the LED. And we also save the milliseconds so that we can then be, and what that does is it resets our interval timer. And so we go through, if we know we're going to change state, we reset the timer, we change state, and then we go through it again. And it's a very simple blink without delay. I heartily, encourage you to use this as your standard blink program going forward because it allows you to do other things while the blinking is going on.